Hello, good morning dear students. Today we are going to discuss a new very interesting topic, that is the relationship between electricity and magnetism. So this topic become interesting because of only one man, that is Hans Christian Ørsted, pronounced Ørsted. In 1820 he made a discovery. That discovery changed the world a lot. So what is that discovery? Actually, Hans Christian Ørsted want to prove in his laboratory that there is no relationship between electricity and magnetism. And he is going to his laboratory every day to prove this statement. There is no relationship between electricity and magnetism. So he want to make this as a theory. In order to make it a theory, he wants some experimental proof. So every day when he go to the laboratory, he was observing. He made one straight current carrying conductor and he placed a magnetic needle over this current carrying conductor. This magnetic needle over this current carrying conductor. See, it was placed like this. This is a magnetic needle. As we see the magnetic needle inside a compass, little more bigger magnetic needle whose center is placed in just the center of the current carrying conductor. So what happens, this will be saying there was no movement for this magnetic needle. No deflection was seen in the position of the magnetic needle. So he made or concluded that there is no relationship between electricity and magnetism. So he was going to write down this as a theory and he wanted to publish this. One day when he accidentally came to the laboratory, he saw that the magnetic needle was placed, accidentally it was placed parallel, means over the conductor. It was placed over the conductor parallelly to the conductor, means magnetic needle was placed like this. At first case it was placed perpendicular to the conductor like this. If the conductor was like this, magnetic needle was placed like this. Next case, accidentally he does not made it as it is, but accidentally it came to this position. So what happens when it was placed parallelly, when he started passing electricity through the conductor, it was staying like that. Then he just passed electricity, put on the switch to pass electricity through this conductor. What he saw is, so this was connected to a conductor. So just I am giving only an electric cell. So if it is connected to an electric cell, and electricity will be passing over this conductor, isn't it, from positive to negative. So that is, electricity is passing through. Let us make the magnetic needle here and let us show the passage of electricity. So electricity is passing through this direction, y to x direction. So he saw that there is a deflection in the magnetic needle and the deflection was towards the left side. This side there is some deflection. Magnetic needle was made like this. It was made deflected like this and it oriented in this direction. So he concluded that every conductor, around every conductor, an electric current, around every conductor carrying an electric current, there is a magnetic field. Simple. Around every conductor carrying an electric current, there is a magnetic field. That he concluded. And this conclusion is very important in the field of physics. Based on this fact, there is a relationship. He found that there is a relationship between electricity and magnetism. Then many of the scientists, and he also think about what will be the reason for this deflection. So he found the answer for that thing. What will be the reason for the deflection is that here is a magnetic needle. We already studied that around every magnetic substance there will be a magnetic field. The space or area around which the particle other things can experience a force of attraction or repulsion towards the magnet. That area is called magnetic field. So there is a magnetic field for this magnetic needle. And it was placed as like that. If no current flows through that, it is placed At that time also there is a magnetic field around the magnetic needle. But when current passes, there is a deflection, which means that into the magnetic field of magnetic needle, some other magnetic field come and play. That is the magnetic field due to the current carrying conductor. That is, a current carrying conductor acts as a magnet at the time of passage of current, which is not so very much strong magnet. It will not act as a strong magnet, but it consists of a magnetic field anyway, a very small magnetic field. So because of that magnetic field, this magnetic needle made a deflection. So due to this magnetic field, what happens? It comes to play and make an effect on the magnetic field of magnetic needle, and it get deflected. So that was an important discovery, and later based on this discovery, even electric motor, the dynamo, or what do you say, mini motor, you know very well, even that thing worked due to the magnetic field. And it is because of that, it is because of this discovery later we found what we don't, automobiles, all motors, fans, everything is working due to this discovery. So he's an important person in the field of physics. Hans Christian Ørsted, in 1920 he discovered that around every conductor carrying an electric current there exists a magnetic field. Later what happens, our Andre Marie Ampere, you know who is that? So he discovered, or he found the direction for this magnetic field by using a rule called Ampere's Swimming rule. This Ampere's Swimming rule is very simple. Just we have to imagine ourselves as an electric current, and if we are flowing towards a magnetic needle, the magnetic needle will deflect towards our left hand. What is that? We have to imagine ourselves as an electric current. So if we are swimming towards a magnetic needle, the north pole of the magnetic needle will deflect towards the left hand. That means left side, to our left side. See, in this case, let me redraw it once more. I am only showing the xy direction. Okay. So here is the conductor. So we are imagining ourselves as swimming from y to x in the first case. That is, current is, our swimming direction means the passage of current. We are imagining ourselves as the current. So here, see, this current is passing from y to x. We are imagining we are swimming from y to x. Then if there is a magnetic needle placed here, that magnetic needle will be, its north pole is deflected towards the left side. Left side means it is deflected to this side. So magnetic needle deflected towards the left side in this case. North pole deflected towards the left side, not magnetic needle, sorry. North pole of the magnetic needle deflected towards the left side. In the next case, let us imagine we are swimming from x to y. That is, the current is passing from x to y. At this time what happens? Here is the magnetic needle. Here is the north pole. Here is the south pole. What happens? Again, the north pole is deflected towards the left side. We are swimming from x to y. So our direction is from here. Our left hand is in this direction, isn't it? Our left hand, this direction. So we are swimming from x to y. So the north pole will be deflected towards the left side. That is this side. Or the magnetic needle will be oriented like this. So that was Ampere's swimming rule. Very simple. Just we have to let the observer have to imagine himself as the electric current passing over a conductor, passing through a conductor. Then the magnetic needle, north pole of the magnetic needle will be deflected towards his left hand. That is Ampere's swimming rule. Okay. So that's all for today. Thank you. Have a nice day.